So my idea here is to bench test some concepts for ballast for a submersible rover. So what I did, this is a basically just a micro torch. One tank has butane in it, which I don't need. I just need one. And this other one has, I can't remember, is it nitrous oxide or nitric oxide? They're different chemically, but so this is what you get in whipped cream containers. So I'll go ahead and show you. I just basically, you turn these knobs, that'll push this plunger up and down. The reason I didn't do like direct mechanical manipulation of the plunger is for every, if I half the volume here, that's double the pressure. If I, cut it down to a third, that's like 3 times the pressure. That's a lot of stress on this plastic, on that syringe, large syringe, and my mechanical system. So basically this will operate slightly above whatever pressure it needs to. I mean, that's the beauty of it. It doesn't over pressurize stuff. So if this is underwater, I think every 30 feet underwater, atmospheric pressure goes up by 1. So I'm not going to be working at great depths with this thing, most likely. So yeah, it'll just avoid all the high pressure issues with direct mechanical movement of the plunger. So I'll go ahead and turn this valve. I'm going to turn the green valve. That's the nitrous or nitric oxide valve. So you can see the plungers moving. They got these bands to help retract it. So what the beauty of this setup is, they can bleed out the air through this other valve. So the butane valve. That's, oops, well, I think I just lost one of my binders. Alright, well, I'm going to shut it down. Okay, now I'm going to, even though I have one busted binder, see if it pulls itself back in. So I know for sure I can't, have to do something different with the spring-loaded tension on the plunger here. But alright, I'm going to turn the butane valve. So the butane valve is bleeding off the nitric oxide that built up in the syringe here. And I can shut that off. Then I'll go back the other way again. Yeah, you don't really hear anything until you alright, I don't want to bust any more binders. They're like 15 cents a piece. Alright, bleed it off. Of course, then the next step will be to motorize my valves, because I want this to work remotely, obviously. Otherwise, there isn't much of a rover. So here are my 2 gearhead motors fastened to the micro torch. Archer torch is what they call it. So actually, I do have a lathe and small machine shops that could actually make metallic couplers or any kind of coupler with any kind of material. But so I lucked into, I just kind of was over at Axman's, and I, anything I can save labor-wise, I always do. Machining's can be pretty tedious. So I found these couplers fit on the shaft really snug. And then I found these weird guys. There's a pocket there. They fit over the plastic caps of these torches. It's like really stiff. So I actually slide on there. So anyways, the trick was to glue this piece of rubber to this to make my coupler. And I had to experiment with glues. I found that a gel super glue works the best. I tried like hard epoxy, I tried like latex stuff, anyway, super glue kind of actually just melts whatever the two materials are made out of. You actually, so it really fuses it. I mean, it's a super tight glue job. This is a non-failing glue job right there. It's super tight. So anyways, I'll go ahead and put my gearhead motors, just kind of temporarily mount them to this guy, and then my syringe. Show you the general approach that I'd like to take. Eventually, you know, hard fix this all into a more permanent structure. So here's my quick jury rig. I basically just taped these gearhead motors to a stick along with the micro torch. So my couplers are going to open and close the valves here, which control the amount of gas inside of my syringe. So I'll go ahead and just show you what I plan to do. So everything's obviously, I want it to be remote. Everything controlled remotely, so by wires in this case. So that's, oops, that's the wrong one. So that's my release valve. Oh, another nice thing about these rubber couplers, things don't have to be in a perfect axis to each other, otherwise you get binding. Also, they slip when they get to the end. That rubber will slip on the control knobs of the torch there, so I don't end up breaking plastic and stuff. So things get a little less worry about precise tolerances. So go ahead and open. I think this is right. We'll see. Oops, that's closing. So I'm going to go ahead and open the okay, up. Oops. I want to go the other way. Help me, help me. I got to close it. Okay, now it's closed. I don't want to bust my other hands. Alright, now I'm going to release the pressure with my other valve. So anyway, here's my battery. Just touching the wires to these motors down to my battery here. So there we go. Should be automated after that. And I can shut it. I wanna. Okay, I just shut it. I didn't get an extra syringe, so this would be like a forward ballast. This would be the aft ballast. And if I really wanted to, I don't know if I'll ever get this complicated, but I did buy an extra micro torch on eBay used. 2 extra gearhead motors, so I mean I could make it as complicated as I want. I'm gonna go simple first. Just have one cylinder control both syringes for ballast. I think, you know, plus if I ever do lose my machine, I'm out a lot of gear and be a lot of bucks, so try to minimize the amount of equipment I might lose, at least in the first few attempts. If things look like they're working well, I invest more equipment in the machine. So